Sharifah Izzat Azrin with Warpai, and my metric number is 100987.
Hello, my name is Lo Zingmin with metric number 99526.
My name is Kashni Mullidaran and my matrix number is 99381.
Hi, my name is Nurul Inani Shazana binti Mahasan with metric numbers 97754.
For materials that's being used in experiment 2A is first glucose solution. So glucose solution serves as the reducing sugar standard for creating the calibration curve. Second one is distilled water. Distilled water is used to dilute glucose solution to different concentrations. Next, DNS reagents. DNS reagent react with the reducing sugar to form a colored complex for spectrophotometric measurement. Test tube and rack to hold reaction mixture during heating and color development. Hot plate. It heats the test tube to allow redox reaction between reducing sugar and DNS. Next one is Rochelle salts or sodium potassium tartrate. It is used to stabilize the color product formed in the DNS reaction, enhancing measurement accuracy. Next is micropipettes and tips. So it is used to accurately measure and transfer small liquid volumes. Cuvette. It holds solution for absorbance reading in spectrophotometer. And lastly, spectrophotometer. It's used to measure absorbance at 575 nanometer to quantify sugar concentration.
6 samples were prepared in duplicate based on the table given and was labeled as 1 to 6. For test tube table 1, distilled water and DNS solutions were added based on the table given. The sample was then shaken well. Test tube 1 was represented as a blank sample. For test tube 2, distilled water, 10 gram per liter standard glucose solution and DNS solution were added based on the table given. The sample was then shaken well. These steps were repeated for test tube labeled 3 to 6. All the labeled test tubes were placed in a boiling water bath for 5 to 7 minutes. The test tubes were then set to cool. Once cooled, 1 ml of Rochelle salt was added to all labeled test tubes. The solutions were then added to the cuvettes and the results were obtained through a spectrophotometer.
In practical 2A, this experiment successfully established a glucose standard curve using the DNS method and UV spectrophotometry. A strong linear relationship y equals to 1.1559x plus 0.2372 confirmed the method's reliability and the applicability of Beer-Lambert law. The DNS glucose reaction was specific and stable, making it effective for measuring reducing sugar. The practical emphasized the importance of accurate techniques and laid the foundations for applying the curve in further analysis. Overall, the DNS method proved to be a sensitive and reliable tool for quantitative sugar analysis.
The materials used in experiment 2B is the same as experiment 2A, so the stated materials has been explained in experiment 2A, but the only difference is selected drinks. In this case, we use tea as the sample, so the tea acts as the real-world sample tested for sugar concentration.
The sample was diluted in the ratio of 9 to 1, where 9 ml of distilled water was added into 1 ml of tea. The sample was then pipetted into 5 proportions based on the table given. Each proportions were prepared in duplicates. Test tube label 6 was set as a blank sample. Distilled water and DNS reagent was then added to all labeled test tubes based on the table given. Each labeled test tubes were then shaken well. All the labeled test tubes were placed in a boiling water bath for 5 to 7 minutes. The test tubes were then set to cool. Once cooled, 1 ml of Rochelle salt was added to all labeled test tubes. The solutions were then added to the cuvettes and the results were obtained through a spectrophotometer.
In Practical 2B, the DNS method and standard curve from Practical 2A were used to estimate reducing sugar concentration in unknown sample. Absorbent reading at 575 nanometer from variance dilution show decreasing value with higher dilution. With valid glucose estimation between ratio 1:2 and 1:10, the undiluted sample had the highest concentration, which is 0.881 gram per liter. While overly diluted sample fell outside the curve reliable range. The experiment emphasized the need for proper dilutions and precise technique, demonstrating the DNS method effectiveness for quantitative sugar analysis when supported by accurate calibration.
Practical 2A and 2B, we learn new concepts, skills, and techniques. We prepare glucose solution at different concentrations and reacted them with DNS reagent, which help us understand how reducing sugars behave in calorimetric tests. We measure absorbent at 575 nanometer and apply the Peirce-Lambert principle to connect our experimental data with theoretical knowledge. Using a standard curve to estimate sugar concentrations in unknown beverage sample gave us practical experience in applying our earlier results. During the experiment, we faced several challenges. We found it difficult to consistently match color intensity across test tubes, especially when heating times or mixing varied slightly. We also realized that precise pipetting and careful priming were crucial, as small mistakes affected the absorbent readings. Interpreting absorbent data from beverage samples was confusing when the value fell outside the expected range, possibly due to interfering substances or dilution errors. Hence, to improve, we suggest standardizing heating times and mixing procedures, practicing pipetting beforehand to reduce volume errors, and provide clearer example on how to use calibration curve to help avoid mistakes in data interpretation.